Hi guys! Alright, we are reviewing for our Chapter 3 test, so I'm going to do a few of our review problems here on a video for you in case you're struggling. And so let's go ahead and get started. Okay. Oh, I better make myself small, huh? You probably can't see anything past me. Okay, that should be better. Alright, so let's start just taking some derivatives, right? And some of these are easy, some of them are a little bit more complicated. So let's take a look. All right, so number 1, x to the 4th. So this is just a straight power rule, right? They're all different terms. There's nothing fancy about any of them. So we just have 4x to the 3rd minus 9x squared plus 1. All right, that one is really simple. Okay, and then the next one, number 2. So this one is, again, a straight power rule, but it's a little bit more complicated because it's got those fractions in it. So we bring the fraction down, so we have 1/3 x, and then we subtract 1 from 1/3, right, which is negative 2/3, okay? And then on our next one, we bring the negative 1/3 down, so that gives us a positive 1/3 there now. And then we subtract 1 from negative 1/3, which is negative 4/3. Okay, now number 3. So this one, we could use a quotient rule, but we don't really need to because it's not a function over a function. Really, this is the same as 3/4 times t to the negative 3. See, they're the same thing, right? Because, you know, when you see two functions being divided, like one function on top of another function, that's usually like a key that you're going to do the quotient rule. This is not a function. This is a constant divided by a function. So it would be a lot of extra work to do the quotient rule for no real reason. So we have a constant in front of it, so it's 3/4. So we just bring the 3 down. So we have negative 3 times 3/4. There's that 4. Okay, and then t to the negative 4. And so then we can simplify that by saying that's negative 9/4 t to the negative 4. And that's it. All right. Number 4. The big key that I see right here is that this is the square root of a function, which means it's a function inside of a function, right? Because the square root is a function, and then the x squared minus x is another function. So it's a function inside of a function, so let's write it as a power, x squared minus x to the 1/2. Okay, and so then this would be a chain rule thing, right? We take the outside, the derivative of the outside first, 1/2. Then the inside stays intact. When we first eat our chocolate, the inside stays intact, but we take the derivative of the outside, okay, and then we're going to eat the inside, right? So then we take the derivative of the inside, which is 2x minus 1, and yeah, we could just leave it like that. I mean, we could do some like fancy stuff, so we could write it like 2x minus 1 over 2 times the square root of x squared minus x. But why? Like, why would you do extra if you don't have to? Now, to be fair, sometimes, excuse me, you love this cold, right? Okay, sometimes you're going to need to simplify things. Sometimes you do have to actually make it, you know, look a certain way. So you have to recognize that these two functions are equivalent to each other because although you don't normally have to simplify, there's sometimes you might have to at least do a little bit. Okay, let's look at number 5. Number 5, I'm just going to erase these so that I can have some more space. Okay, so number 5 says it's a function times a function, which is an inside of a function. Okay, so there's like a couple things going on. See, we have a product rule going on here because we have one function times another function. But then if you notice this is a function inside of a function, right? Something cubed is a function, and then x minus 1 is also a function. So we're going to have to do a chain rule And we're going to have to do a product rule. So let's set this up first. I really don't like that this is called g of x, because then we can't name any of our functions g of x. So let's call this h of x. Okay, so we're going to find the derivative h prime of x, and we're going to set that equal to, okay, so we're going to set up our product rule because we know it's a product rule, because we see the product of two functions. Okay, then we see that our first function is x, so the derivative of that is 1, and our second function is x minus 1 cubed, and now we have to find the derivative of that, which entails using the product rule, or the chain rule. So that would be 3 times x minus 1 times the derivative of the inside function, which happens to be 1, so it doesn't actually need a tack on there. And then this becomes the squared, right? So it's 3x minus 1 squared, and then the hook-on factor on this one would just be a 1 for the chain rule, because the derivative of the inside function is 1. Okay, so then we just do the product rule, and we go fig plus gif. So we have x minus 1 cubed plus 3x x minus 1 squared. And that's our answer. Let's see, it's number 5. Yep. And that's all. Okay, number 6. Now this one is a quotient rule thing, and we look at it and we go, the first question I would always ask when you see something that's a quotient or a product rule, ask, can I simplify it, right? Is this something where I can just distribute numbers in, or I can just divide numbers out, and I can simplify it and make it so much easier? Well, I don't really see a way that we can simplify this. I don't see anything that could factor to x plus 1, so there's really not a good way to divide x plus 1, so we're just going to do the quotient rule. Okay, so let's say, okay, so we could do low d high minus high d low, or we could do fig minus gif over g squared, however you want to think about it. So low d high, so that's x plus 1, x plus 1 times the derivative of the upper function, which is negative 4x, low d high, minus high d low, negative 2x squared, times 1, okay, because that's the derivative of the bottom function. Square the bottom, and away we go. Okay, so we could do a little bit of simplifying if we want. Negative 4x times x plus 1, plus 1. And that's plus 2x squared all over x plus 1 squared. And I don't know that we want to go any further than that. Yeah, you really don't. You really, really don't. I mean, like, again, sometimes there's a few of us who hate to simplify. And sometimes you have to just to be able to match it with something else. Because you could recognize that this is going to become an x squared term, so we can probably combine it with that x squared term. We have an x plus 1 at the bottom, so you know what? Let's just simplify this one just for kicks and giggles. So we have 4x squared minus 4 plus 2x squared. And then we have an x plus 1 on the bottom squared. And then we've got negative 2x squared minus 4 over x plus 1 squared. Yeah, I don't know that there's more that you could do, because you could take out the negative 2, but we'd still be at x plus 2 there, so then I think we're pretty good. Okay, so simplify or don't, it just depends. Remember, don't simplify yourself out of a right answer, okay? So don't. If you are afraid that your algebra is going to screw you up, just stop where you're at. And in our class, I'm good with you boxing things, but a strategy for the AP test is that don't box anything, because if you declare it as an answer, they have to say that was your answer. But what if you have the right answer above, and you didn't box anything, they can say that must have been your answer above. Okay, so let's look at number 7. So this one again screams quotient rule, but then you look at it closer and you think, wait a minute, each of those terms can be simplified, right? X cubed can be divided by x squared, and x squared can be divided by x squared. So really, this can be like x cubed divided by x squared minus x squared divided by x squared. And now this just becomes x, I'm thinking ahead of myself, x minus 1, which the derivative of that is 1. So it's really that easy. If we had done the quotient rule, we would have found that. But, yeah, it's a lot easier. This one does have a domain restriction, though, because when we do all this algebra, we get rid of something that was in the bottom of the denominator of the fraction. But x cannot be equal to 0. So it doesn't hurt to write that, just because if you have a domain restriction in the original function, you're going to have a domain restriction in the derivative, and you don't want to just kind of like gloss over the fact that, like, as if that didn't exist. Okay? So that would be 1 when x is not equal to 0. And then the last one on this video is going to be -3 times 2 minus 3x squared. Now, here's the thing. This is the mistake that I see all the time, and sometimes not so much in calculus, but that we forget that there's this squared here, and we're like, oh, I can take this -3, and I can just multiply it by 2, and then I can just multiply it in here. But, right, you cannot override this exponent. You cannot override that exponent and do multiplication before you do an exponent. You just can't do it, okay? So, don't do that. Don't do it, okay? Just leave it as is, and we'll just derive it as is. So you could do some algebra here if you really wanted to FOIL, but I think the chain rule is going to be just as easy. So let's do the chain rule. The outer function, so we have 2 times -3, which gives us -6, with the inner function still intact. And then we multiply it by the derivative of the inner function, which is 3. So we have 18 times 2 minus 3x squared. And that would be our final answer. All right, that is, oh, sorry, gosh, we are not going to be squared there. Well, let me just lead you astray. The squared went away, so you're just going to be 18 times 2 minus 3x. Okay, so that is the only stuff for this video. I will do a few more videos here with a few other problems. Okay?